Hi viewers, this is Sri Ramulu, DL in Physics. YouTube channel is s.s space physics. So today's topic is growth of current in inductor resistor circuit or LR circuit, right? So how the current increases in the LR circuit, that is we have to discuss here. Consider a circuit containing resistance or inductor L, a two-way key and a battery of EMF connected in series as shown in figure. So in the figure it is given how the inductors and resistors are connected. They are connected in series like this. They are connected series, and see here there are the two-way keys. Two-way keys means when you connect the S, so here you can connect the S to B and you can connect the S to A also. But when you connect the S to B, then what happens? This circuit will be closed. When you connect the S to A, then above circuit will be closed. So when you connect the S to the B, then this circuit closed, and this circuit contains a battery also. So battery, what it can do? It can give the current. So it can increase the current, it can produce the current. That current can flow through the resistor and inductor like this. But when you connect the battery to the A, then this circuit will be closed. But in this circuit, if you observe, there is no battery. So when there is no battery, then what happens? So whatever charge this contains, or whatever current this two component or element contains, they start to decrease. Okay, so that is why here there are the two ways are there. In two ways. In one way, what we can do? In one way, we can increase the current by connecting like this, and we can decrease the current by connecting like this. Okay, so when you connect like this, then what happens? Current starts increasing. So increasing current is also called as growth in current. So in which circuit? L and R circuit, or RL circuit. So you can call in any manner, right? When switch S is connected to the B, so like this, connected to the B, the current in the circuit grows from the certain value. That means the inductance opposes the growth of current, right? So when the current is increasing, inductance main work is to decrease the current. Okay, so according to Lenz's law, this is due to the fact that when the current grows through the inductance, a back EMF developed which opposes the growth of current in the circuit. So what it will do? So here back EMF means a EMF which can oppose the current, right? So the rate of growth of current is reduced. So it cannot as the current passes, it cannot make to increase the current. So that is the rate of growth of current is reduced. Okay, right. And next, during the growth of current in the circuit, let I be the current at any instant t. So I is the current, okay, at any time. So any time means after 1 hour, after 2 hours, after 3 hours. Then the back EMF developed in the circuit will be L into di by dt. So what I said just now, back EMF will be found. That back EMF is what? Simply di by dt. And how we get this di by dt? So you know, so that is according to Faraday's second law. So Faraday's second law is epsilon is equals to d phi by dt actually. But when coils is there, then magnetic flux will be formed. That magnetic flux is always directly proportional to the current, and flux phi is, so remove the directly proportionality, write equal and constant, that is Li, where L is what? It is a constant called inductance, self inductance. And take this formula and substitute in this formula, then what you get? So you can get this one, where is that? That is L into di by dt you can get by substituting this. Okay friends, right. Next, the effective EMF in the circuit will be, so effective EMF in the circuit is, effective means, so total EMF of a battery is E, and some amount of EMF will be developed at this point. then remaining is what? It is E minus L into di by dt. So, that is effective EMF. Okay. So, effective EMF this. According to Ohm's law, this should be equal to the resistance into current at that instant. So, what is the Ohm's law? Ohm's law is V is equals to resistance into current, right. So, this total is equals to this. So, right, we have made it is equal, and from this see here it is minus term is there, bring this is this side and Ri is this side, then you can write this one. Next, okay, after this what we have to do, L and dt bring this side, okay, only L and dt, and this whole bring this side, okay. So, E minus Ri, if you bring this side it divides, and L into dt, L by dt goes that side, and it becomes dt by L, and here like this. And now integrate, so before multiplying above equation with respect to equation with minus R on both side. Yes, multiply this side and this side, minus R is multiplied on either side. Next, integrating above equation we have. So, if we integrate above equation, then we get this one, and here it is dt is there. So, then minus R by L is constant, take it outside. Yes, taken outside. Next, and here see here. So, this is the formula, no change, and the next step is integration dt is simply t only, and I have kept one constant. Why? Because when we integrate on either side, according to mathematics, when we integrate on either side means both side, then what happens, we must keep one constant, that is either b or c or a, whatever it is. That constant is called integration constant. Okay friends, and here if you observe this one, so if you differentiate E minus Ri, if you differentiate, what you get? You get it is a constant term of battery, so it is 0, and it is C minus E minus Ri. If you integrate, if you differentiate 0 minus R di we write. Okay. So, when you integrate to this, then we get minus R di. So, this minus R di is presenting above, here minus R, here di. Okay. So, minus R into di presenting above. So, that means its differentiation is above, right. So, when its differentiation present above, then differentiation of its above, then we write simply log of f of x only. So, that means whatever function it is there, so simply write into the log. So, same thing written is here. So, this is written in log base e. Okay. So, it is a formula. When one function is there, its a definition above, and if you integrate, then you can get right, it is a log function, it is a formula only, keep in mind. And next, okay, where a is a integration constant, just now I told you, when we integrate on either side, then we must have put a constant. To get a value, we have to apply the initial conditions. What are the initial conditions? At time is equals to 0 means the beginning, before starting the battery, before switch on the battery, its time is 0, then current cannot flow, that current is also 0. Okay. When time 0, current is 0. Take these values and substitute here. So, time 0, current 0, right, time 0, current 0. Then what you get? You get a value as like this, and take this a value and substitute here in the equation, in equation 1. Okay. Then see here. So, a value is substituted here. Okay. And now bring this a value this side. So, right, it becomes minus. Why it is a plus? When you bring this side, it becomes minus. Now, it is in the form of elect, it is a value and it is a b value, log a minus log b, log a minus log b is log a by b, we know that is. So, written it is log a by b without changing this, right. And now So when log term is written in the form of anti-log, means exponential term. So when it is in the form of like this, then see here, log y base e is equals to x, then write x value on e power x and make it equal to y. Okay, so like this only, y is equals to e power x. So apply this formula to this one, then see it is written like this. Okay, what is be written here? See, first observe, e is there, so 2 e power x is written and it is made to equal y. So write e power, write it is and make equal to it. Okay, write like this. So e power of minus r by l into t, this is, and it is separate this, so separated like this, e by e is, so that is how much, 1. Okay, 1. And now bring this is this side and it is this side, then what you write? You write it is like this, and keep, so right here r by e, so e by r, that is r by e. Okay, right friends, yeah. So r by e, bring this side it is brought here, so e by r, so voltage by resistance is current, Why it is written as I naught? Why? Because E is the EMF of battery and R is the resistance. Then EMF battery contains the current, that is maximum current, that maximum current is denoted by I naught. I naught indicates maximum current. So finally we write it is the equation like this. So this is the equation, this equation indicates the growth of current. Equation 2 means above equation gives the current in the circuit at any time t. It is obvious from the figure that. So here see, let me change above equation. So it is a above equation, and if you keep it, so I value, what is happening here, I value is increasing. Suppose it is increased to the maximum value. Now substitute I is equals to I naught here, I is equals to I naught substituted. Then what happens here? Okay friends, so I is equals to I naught, substitute here. So that means what it indicate to us? So it indicate to us at what time current, maximum current increases in the circuit. That is we have to know here. So here how much time will take to increase maximum current? Suppose I is equals to I naught, so it is increased. Then how much time is taken? So see here, in the place of I naught is substituted, and this I naught multiply inside. So multiplied, and bring this I naught this side. Yes, brought, it is now it is a plus. If you bring this side, it becomes minus. Both term gives us 0 value. Okay, right? It is 0. If you bring this side, that is also 0. So so finally what you write? E power of minus r by l into t is equals to 0. So when this term is 0, you know, when time is equals to infinity, then only it is 0. Why? If you substitute e power minus r by l into t in the place of t, infinity. Infinity, everything is infinity only, so that is e power of minus infinity. So e power of minus infinity can be written as 1 by e power of infinity. 1 by e power of infinity is infinity only. So something by infinity is always 0. So that is why we get as 0. It is when time is equal to infinite. So to increase the maximum current, to increase the I becomes maximum I naught, then it takes how much time? This much of time it takes. Hence the current never attains the value I naught, but it approaches asymptotically, unexpectedly. It approaches unexpectedly and asymptotically, right? A graph between current never and a time is shown. Sorry, it is not never. The graph between current and time is shown. So current and time is this one, and it never reaches to the infinity. So that is why here some gap is given here. Okay. And here when t is equals to L by R, if it is substitute t is equals to L by R, then what you get? You get this value. Okay, so L by R, L cancel, R cancel. Then see, it becomes minus 1, and if you want to remove the minus 1, write it is 1 by and take LCM here, you can write like this, and E value we know that is 2.718, or sometime people may write 2.72 also. So it is exactly value, it is approximately value. Okay, I is equals to I naught, this one, and you can get like finally this one. So what it indicates, when we got this one, when time is equals to L by R substituted, then only we got this one. So what is this time t is equals to L by R? L by R is called time constant of a LR circuit. So this time constant is also denoted by a letter lambda. Lambda is equals to L by R. So thus after the interval of L by R seconds, the current reaches the value of 63%. 0.63 means in terms of percentage 63% of maximum current. Okay, so current is increases how much, you know, only 63%, and the remaining percentage 37%. To increase the 37%, how much time it takes? This much of time, infinity time it takes. The value of L by R is called time constant denoted by lambda. Therefore, the finally that equation we can write like this, above equation. Which equation? This equation. So okay, this one, this one. So can be written as like this. Like this we write, and differentiate not this equation, differentiate just what I shown above, differentiate that, and see here differentiation of I generally I is equals to I naught 1 minus e power of minus R by LT is formula, and if you differentiate on either side, then you can get like this, and after differentiating multiply differentiation inside. So so here not in first multiply I naught inside. So I naught into I is I naught, and here I naught into e power of minus L R by L into T. Now differentiate it. So its a differentiation is 0. Its differentiation we know like this, when e power of ax, its differentiation is a into e power of x. So x factor comes down, so here t factor came down. Okay, and again, so it is, and again this value can be written as from from the equation 1 only. So like this. So it gives to us the above equation gives us rate of growth of current, right? So rate of growth of current is like this. So it is a time dependent only. So okay friends, this is the derivation of LR circuit. Okay friends, thank you. Don't forget watching this video till the end and subscribing